Hey pre-calculus. Today in class we were talking about the law of cosines, and I just wanted to give you a couple examples for your notes. So in this first example, we've got a side, the included angle, and another side. This technically would be side, angle, side if you cared about the case. Some textbooks will teach law of cosines, telling you like certain cases use law of cosines or law of sines. Here, what I like to do is if you're given a situation like this and you try to use law of sines, so you say sine of 82.4 over C equals sine of, let's call this A, I guess, A over 212. It becomes really obvious right away that law of sines isn't going to do you any good here because we don't have one whole fraction filled out in the law of sines. We have too many missing informations, too many variables here. And so law of sines doesn't work in this situation, which means we have to use law of cosines. Now, there's 3 variations on law of cosines, but all of them amount to the same thing. So I'm going to write down this variation and then show you why. The first one that I'm going to use here is c squared equals a squared plus b squared. It looks a lot like the Pythagorean theorem. Minus 2. These 2 variables come next, a, b. And then cosine of whatever the first variable is, so c. Now this is side c and this is angle c. Notice this is lowercase and this is uppercase. Okay. So if I'm going to plug my information that I've got into law of cosines, then I would say, let's see, little side c, I don't know. A squared is 212. B is 388 minus 2 times 212 times 388. Cosine of my angle, which is 82.4 degrees. Now the reason I say there's 3 versions of this, you could also say that b squared equals a squared plus c squared minus 2ac cosine b, and a squared equals b squared plus c squared minus 2bc cosine a. These are all variations, though, of the same equation, basically. It's just depending on whether you're solving for side A, solving for side B, or solving for side C. No matter what, though, whatever you're solving for, it's always going to be the 2 sides that are given, squared each, minus 2 times each of those sides, times the cosine of the included angle, or the angle in between them. Okay. Now, law of cosines, even though it looks really gross and like there's a lot of things going on here, the nice thing about it is that your calculator knows order of operations. I mean, we should too, but when you can take shortcuts, why not? So I've got 212 squared, I can plug it in, plus 388 squared, minus 2 times 212 times 388, cosine of 82.4. So then I get c squared is equal to, let's see, 173,730.2367. And then I can take the square root of both sides. Oops. Second square root, second ANS. And I get c is approximately 416.81. And if there were units here, it would be miles or feet or whatever. So then after you find c, so this guy is 416 point, well, let's just call it 0.8 for right now. Oh, and it's feet, because I've got units there. Okay. Then you can go ahead, if you're solving the rest of the triangle, now I have an angle and an opposite side. So now I can use law of sines to help me solve for the rest of the triangle. When law of sines typically is a little bit less work. So I would say sine of 82.4 over 416.8 equals sine of, let's say, a over 212. And we have other notes on this, so I'm not going to spend some time going through it, but you can see that you could take law of sines and solve for angle A, and then use that to find angle B. Okay. Law of cosines also works when you're not given any angles. Notice here I'm only given all 3 sides. This would be the side, side, side case for a triangle. So here I can solve for any angle that I want to. I'm going to go ahead and pick A just because it's nice and there and easy. So if I solve for A, then I'm going to do a squared equals b squared plus c squared minus 2 times b c cosine of a. And I don't know what a is, so I'm going to solve for it. Here, unfortunately, you can't just throw it into your calculator. You are going to have to do work and follow order of operations pretty carefully, actually. So I'm going to square 5 and get 25. 8 squared is 64. 12 squared is 144. Let's see. 8 times 12, what's that? 96 times 2 is 192. Cosine A. And now let's see, there's a lot of addition and subtraction here, and it's really, really tempting to go 64 plus 144 minus 192, and to put these three numbers together. The problem with that, though, is that this negative 192 is connected to the cosine with multiplication. It's negative 192 times cosine A. And so this multiplication right here has to happen before these do because of order of operations. Multiplication comes before addition subtraction. And so when you're simplifying it, you cannot put this with these two guys. You're going to have to combine the 64 and the 144 and deal with them separately and deal with this guy all by itself. So I'm going to put the 64 and the 144 together. When I add those, I get 208. And now since I'm solving for cosine of A, I really want to start solving, so I'm going to start doing reverse order of operations. Since this is a plus 208, because there's a hiding plus sign right in front of it, I'm going to subtract 208 from both sides. The 208 cancels. 25 minus 208 is negative 183. And then since the thing that's connecting negative 192 and cosine is multiplication, I'm going to divide both sides by negative 192. When I do that, I get a decimal of 0.953125. And then to cancel the cosine out, I need to take the cosine inverse of both sides, or the arc cosine of both sides. So that cancels that cosine and leaves me with angle A. And when I take the arc cosine of the decimal that we got from before, I get 17.6 degrees. And then again, as soon as you have one of your angles and you've got all of your sides, now I've got an angle on opposite side. I can use law of sines to help me figure everything else out. So law of cosines really just helps you get the first missing information that you need, and then you can use law of cosines after that. All right, that's it for notes tonight, guys. Thanks, and I will see you tomorrow.